Hello, this is Don with MecSoft Support. Today we're going to be discussing Visual3DPRINT 2017. And in this video, we're going to be doing Quick Start Guide number 2, and we'll be looking at the offset and split commands in Visual3DPRINT. Now, after you install Visual3DPRINT, you should see the Visual3DPRINT main menu here on the plugins pane. If you don't see that menu, go to the left and select the Application Manager. In the Application Manager dialog, make sure that the box is checked next to Visual3DPRINT so that the plugin loads the next time the product runs. Now, also, I wanted to talk about the Visual3DPRINT main menu. If you drop down the main menu and pick Welcome, you will see the Welcome dialog. Now, this dialog contains resources that you can use to learn more about the product. Specifically, if you want to go through this guide using a PDF document, you can select the Quick Start Guide option here, and it'll display a PDF document with 3 chapters. The chapter we're doing right now is Chapter 2, regarding offsets and splits. Okay, let's close that. Now, let's go over the steps we're going to do in this video. First, we're going to launch Visual3DPRINT and open the part file. Then we're going to diagnose the mesh for possible problems. We'll use Stitch and Close to combine and fix the mesh. Then we'll use Offset Mesh to create a uniform wall thickness. And finally, we'll split and cap the mesh. Okay, let's open the part file. Go to the main menu in VisualCAD and select Open. Navigate to the Quick Start folder in the install path of Visual3DPRINT that you see here. Then select the part file 3dmold.vcp and then pick Open. What you see here is we've got a mold half of a 3-dimensional part, and you can see that it's appears to be a solid part. And the first thing we want to do, as in any part that you open in 3D Print, you want to do some diagnosis to make sure that you're working with a clean model. So, before we do that, however, let's go up to the Visual3DPRINT tab, menu and display the browser. Now, the Visual3DPRINT browser displays on the left, and as I've discussed in other videos, it has a top menu area, a tab menu area, and it has a data area where all the objects that you load or create are listed. It has a toolbar below that, and then it has an information window below that. Now, this information window doubles for the command option dialogues when you select the command. Now, up here on the menu area, you have a Create tab for creating mesh objects. You have a Model tab for modifying your model. You have an Inspect and Modify tab where you can analyze and manipulate your mesh model. You have a Repair tab where you can diagnose and fix various problems with your mesh. And you have a 3D Print tab where you can set up your part and print it to your 3D printer. Okay, let's select the Create tab. Now, the first thing we want to do, as I mentioned previously, we want to do a diagnose to see what kind of mesh model we have to deal with. So if we go to the Repair tab, select the Diagnose tool. We'll window select all of our part, right click, and the Diagnose dialog displays in the information window, and we'll pick the Run Checks button. As you can see from this part, we have over 30,000 open edges. We have to fix those before we can send it to the 3D printer. These other areas, they're not as critical as the open edges area. So let's close that. To fix these, we're going to use a command called Stitch and Close. Now, what that's going to do is it's going to analyze the entire mesh. It's going to stitch all the edges together so that there's no open areas in your mesh, and it's going to close off any meshes that are missing, causing the mesh to be open. So let's select that, select your entire mesh, right click, and let it calculate. Now it's finished, so let's do another diagnose. Select the mesh. As you can see, we only have one mesh in the data tree now. And we'll do a run checks. And we see they have 0 open edges. That's what we want. Close that. Now, what we're going to do next is we're going to offset this mesh. Now that we have a single mesh in the data tree, we're going to offset the mesh to create a uniform wall thickness. Let's go to the Model tab and we'll select Offset. Select the mesh, and then for the offset distance we're going to enter 0.1, so it's going to be 100 thousandths of an inch thick, and we're going to use a tolerance of 0.01. So we're going to have a 10 thousandths tolerance. Let's run the offset. Okay, so now you see we got 2 meshes in the data tree, and one is an offset of the other. Now the best way to look at this, you see these checkboxes to the left of the meshes. That allows you to turn a mesh object on or off. If you don't see these checkboxes, there's an icon down here on the toolbar that says Toggle Hidden Objects. So if you select that, you'll see that the checkboxes go away. So if you check that box, you'll see they appear, and then we'll turn off one of the meshes, and if you look in the display, you'll see that one is an offset of the other. You see that? Okay, so now we have 2 meshes in the data tree, and now what we're going to do is we're going to split the mesh to create a cavity side of this part. So let's go to stay on the Model tab, and we'll pick the Split command. Select both meshes, right click, and you'll see that down here in the options dialog for the Split command you have a slider, and then you have a slice plane that displays on the part. So when you move the slider up and down, you will see that the split plane moves with it. Now you can adjust the slider to locate the cutting plane, or you can select a point on the model by selecting this button here. Let's just move the slider to a good point that we want to split the model in, and below it you see that you have the option to cap the results or don't cap. This allows you to not only split your model, but the open ends that you split it will be capped to close a closed volume. So we're going to keep the cap results checked, and we'll pick the split button. Okay, the split is done. You see that we still have 2 meshes in the data tree. However, one is the top and one is the bottom. Let's turn the bottom off so we can take a look at the nice uniform wall thickness that was created. You see that it capped the results, so we have a closed volume. This part is ready to 3D print. If you want to make sure, we can go back over to the Repair tab, do another diagnosis, select the mesh, right click, and run check. You see that we have 0 open edges. This part is ready to 3D print. Well, that's it. If you have any more questions, you can visit us on the web at www.mecsoft.com.